All right, Ex6J. So we've moved on from 6I6K, which was to learn the unit circle, the exact values, and now we're trying to see each of those values that you learned, all the X values for cos, all the Y values for sine. We're now going to look at the behaviors, how as you're moving around the unit circle, how the Y values change and how the X values change. And it gives you what we call a sine graph and a cos graph. Okay? So, here's an example to get you thinking how the unit circle dictates the shape of the graph. Let's say we're focusing on sine. Okay? Now, last couple of sessions I mentioned sine represents which value again? Is it your X or Y? It's your Y. So we know every time you get a point on the curve, on the circle, the Y value represents sine of that angle. So whatever angle this creates, the height is the Y value. So this height, that's what sine of the angle represents. Now let's look at the height as we go from 0 degrees, and I will go all the way to the 4 key angles. 0 degrees, I'm going to go to the 4 key points. As I'm moving around, I want you to look just focusing on the height. Okay, don't worry about the X values. Just focusing on the height, because sine represents the height. As I go through those 4 quadrants, you'll see how the graph of the sine graph looks the way it does. All right, so let's start off 0. So here's your line. 0 degrees is at this point. Now at that point, what is the Y value, which is the height? What's the Y value at that point? 0, because we know here has a length of 1. So that point there should be 1, 0. But I'm interested in just the Y value. So you're right, it is 0. Height is 0 at that point. So what I can say is at 0, when it's 0 degrees, sine of 0 gives me 0. Okay, so sine of 0 gives me 0. Then going to the next quadrant. Now I move all the way, so I'm rotating 90 degrees. If I rotate 90 degrees, so that's a quarter turn. At this particular point, what is my height? What's the Y value equal to, Andrea? 1. Because at this point, it's a radius of 1. That point there must be 0, 1. But because it's 0, 1, we're only interested in the Y value. So it is now 1. Then when I go from 90 degrees and I go down to 180, so the next quarter, what is the Y value when I have made a 180 degree turn? 0. So now we're starting to see. So 0, 1, 0. So that's 180 all the way this way. Okay, so at this point, this is negative 1, 0. Y value 0 again. And then at 180 degrees, if I went to 270 degrees, negative 1. So right here, that's a length of 1, but it's in the negative region. So I know at this point, this is now 0, negative 1, and I'm only interested in the Y value, and that is now negative 1. From 270 degrees, I rotate another quarter, and I make 360 degree turn, and it brings me back to 0. Now, let's see how this graph represents exactly what we just described. We can see that the maximum value is 1, minimum value is negative 1, and there's this middle line that seems to be rotating back to 0 each time. You see at 0, 0, right at this point, this represents when angle 0, then I will have 0 height. At this point, when it's 90 degrees, you have height of 1. Because this is all the Y values. This has everything to do with what you just said here. At 180 degrees, the graph drops back down to 0. Then at 270 degrees, you told me 270 was negative 1. And then at 360, you're back to 0. So all those y values, 0, 1, 0, negative 1, 0, is what the sign is telling you. That's what those y values all represent. This is an oscillation. It will keep oscillating in that same manner. It goes up, goes to midline, goes back down, back to the midline, back to the top, back to the midline, back to the bottom, back to the midline, back to the top. That middle is a middle line. That's the median between the maximum and the minimum. And the reason why it keeps oscillating is because the circle repeats its properties every time you rotate. So if you do 2 revolutions, you get 2 cycles. You do 3 revolutions, you get 3 cycles. Oscillating means when you go back and forth. That's what oscillating means. Yeah. So if I show you on Desmos here, let's go back to Desmos. Yes, I know. Here we go. So if I type in y equals sine of x, and let's say x is your angles, I'm going to change a couple of properties here. I'm going to say x is between 0 and 360. And I'm going to change the properties. I'm going to change it to step of 90.
Oh my god! What is that? She's giving them a for real. That's what I thought when I supposed to make rain.
Oh no.
Huh.
I gotta change it to a degree mode, but I don't know how to change it to degree mode. Ah, here. There we go. Degrees. Alright, team. Here we go. Let's just change the height from -2 to 2. Alright. Can you see? Whatever I typed in Desmos, I had to change a couple of settings to make the graph look a bit nicer. For sine of x, I was going for 0 to 360. That's 1 revolution. So you can see it goes 0, 91, 180, 0, 270 is -1, 360, you finished 1 revolution. But as soon as I change from 360 and I double it, okay, it'll be 720. Now if I change it to 720, what we see is it oscillates now. It does the same pattern again, but twice. Okay, now there's a couple of properties that you're trying to learn at year 9 level or enhanced level. There's a couple of properties. There's a maximum and there's a minimum. What's the maximum value and what's the minimum value at the moment? 1 and -1. Now, so that means the middle of 1 and -1, how do you find that? What's the middle of the max and the min? Mean, which is the 0. So if you found the mean between them, you add the 2 together and you divide it by 2, that tells you where the mean is. That mean, so right here, this is the mean. Tells you how to find what we call the amplitude. Can you please write this in? In your graph, can you write the height from the mean to the maximum or minimum should be equal because it's meant to be symmetrical. Okay, that's one of the properties of a trig function. This is your amplitude. A lot of students confuse an amplitude that when I put a negative in front of it, they think that you can have negative values. No, amplitude is just the height between the mean and the max, and the mean and the minimum, they should be the same.
So it's always positive.
Yes, it's always positive. That's what I'm trying to say. So amplitude is always positive. The negative is a different thing. Negative, later on you'll learn, is a reflection. So it just flips the graph. But at the moment, amplitude just talks about mean towards the max and the mean to the minimum. What is that value? That's what the amplitude means. Now, one of the nice things, how do you tell what the amplitude is the number in front of sine. So whatever you times to sine at the front will actually dictate what that amplitude would be. So for example, if I gave you y equals 3 sine of x, the amplitude will be 3. Okay, so that value right here will dictate how high it would be from the actual mean. So I can show you on Desmos, if I put a 3 in front of it, if I put a 3, can you see that the maximum is 3 units away from the mean? And again, same thing, 3 units away from the mean. So from the minimum to the mean, from the max to the mean, it's 3, 3. And that's a beautiful property for trig because it's constant. It's the same height throughout. Okay, and so when you have something in outside that is repetitive in its height, but the height of both, whether you go up or down, is the same, you can use circular functions to model that. Okay, not everything in life has a constant amplitude. So when they have a constant amplitude, so for example, the tides, hypothetically, if the tides go, a high tide and low tide has the same height every day or every hour, you can then model that bit using sine or cosine, okay, elements of that. But obviously, if the high tide is like 10 meters and then low tide is like 2 meters, then that's not the same amplitude. Then you wouldn't use sine or cosine to model that problem. Okay, so there's some properties that we like. One, it oscillates, it repeats itself, has the same timing every 360 degrees, it finishes a cycle. So if there's something out there that repeats itself after a certain period, this is also another nice model. Okay? No.
Next semester. Oh, so it's chapter 6 just for this semester. So it's the third time.
It's to teach you extra, yeah. All right.
We definitely do.
Are we good? So far, so good? All right. Couple things to add here. So you got the amplitude. I'm going to add in another term. Can you write in the period? Okay, the period means how long it takes to make one cycle. Okay, at the moment, the seniors will call it 2 pi because it's every 1 revolution. But in this case, the period is every 360 degrees at your sort of level of understanding. It happens so far every 360 degrees. But it does get affected. You can change. It doesn't have to be every 360. You can change it based on the number. Can you write this in? The number that you multiply to x. So here's a general equation. A sine of, and I'm going to put the letter n times t. Whatever this n is, that will change your period. Now, there is a formula for it. I just want you to write on the side. So if you did ever find a problem, like maybe an extension, if they push it to this point, then the formula to find out how does it change the period is equal to 360 degrees divided by whatever n is. So whatever that number is that you're in front of, oh sorry, not t, x. This should have been x.
Okay, Jada.
So if you have a number in front of x, that's going to change your period. So here's an example. If I gave you y equals 3 sine of 2x. What's my amplitude at the moment? 3. So the height should reach 3 and minimum should reach -3. But the period, I've changed it now. It's not every 360 degrees that it'll make a cycle. By putting a 2 there, my period will equal to 360 divided by 2, which is 180. So for every 180 degrees, it'll finish one cycle. So watch what happens when I put a 2. I go back. I put a 2 in front of the x. And I'll change this back to... See, in 360 degrees, I actually made 2 cycles rather than one cycle because I made that a 2. So if I change that back, so that's one cycle that you were familiar with. But if I put a 2 in front, I make the period shorter. So it takes half the time to make that cycle. So it'll still reach a maximum of 3, minimum 3, but it comes back at 180. So if I change that to 180 now, you can see 180, put a 2. See, 180 still -3, still 3, but it finishes it much earlier and doesn't actually take 360 degrees to actually make one cycle. So you can change the period by timesing whatever x value is by whatever that number is. Yeah. Yeah, this one. Okay, so when you're writing it out, the number in front of sine will dictate how high amplitude is. And the number times the x will change the period, and you can follow this formula here. 360 divided by n will tell you how much you'll change the period by. Okay? So copy that down. No, there's a lot of it is just learning features. Yeah.
For the question, is it saying just estimate? I don't know how,
Yeah. So from the graph, you're just meant to estimate what it looks like. Yeah.
We use Desmos?
Yeah.
Like, we have to,
Yeah. Desmos is probably better. You want one that's drawn to scale.
yeah.
The textbook said the answer was the answer I put was right. You said the answer that I put was right. My math said the answer that I put was right, but then Desmond said my answer was wrong.
Did you type it wrong?
No, I typed it exactly right. It still said it was wrong.
So who's right?
I didn't know.
It's always Desmos.
All right. Next one. Next one. So you got sine now. Cos is exactly the same thing. Features are all the same. Amplitude is still the same. Period is still the same. The only difference is cos represents x values now. So let's do it again. You can see that when we start at 0 degrees, what is my x value in this case? Andrea? 1. We're talking about the x length. So at this point, x value is now 1. That is why when it's 0, we can see it starts off up here. That's at 0, 1. So you start at the maximum, or the amplitude at the very maximum, and then you come down, as you can see, as I head towards 90 degrees the first quarter, x value at this point, remember that point there is 0, 1. That's why the x value at this point is 0, and that's why at 90 degrees, it's saying at 90, x value is 0. That's why it's at the x-axis intercept there. Then from 90 degrees, when I rotate another quarter, I'm now at 180 degrees. What's my x value? -1. So I'm now at the maximum point. So this is now 180, -1. And then same thing, by the time you get to... Whoops, sorry. What did I do? That was... -1, 0. At 270 degrees, we can see, once I rotate to 270, that point there is 0, -1. That's why the x value is 0. And then lastly, you get to the very point, 360 back to 1 again. This is a cos graph.
I need to do this.
And one of the first things you note,
Yeah, that's what I'm trying to do.
have you guys noticed when you were doing 6i6k, that when you do cos of 60, it actually ends up being the same as sine of 30. And the reason, if you look at both graphs, can you see they only differ by two things? They differ in terms of the height here, but really, it takes 90 degrees to make 1, whereas this one is 0 and it's 1. The difference between them is they both have 1 when they're 90 degrees apart. So they're always a complementary angle apart, which means 90 degrees. So 60 plus 30 makes that 90. That's why they complement each other. Visually, you can picture it as well. When you draw a circle, have you noticed that when you do 60 degrees this way, you see cos is the x length. But interestingly enough, you could also say this is 30 degrees here, and that x length is actually the sine of the complementary angles. So sine of 30 gives you that length, and cos of 60 gives you the same length. That's why cos of 60 and sine of 30, they're complementary angles. Visually, that's why it works.
Wait, for example 2, yep. Yay.
Yeah, that's right.
Anything wants as long as they have tonight.
Yes, that's right.
Even like some random numbers like 52 and...
Yeah. Because based on that sort of logic. So if it's 52 here, then it would be 8, what is it? 30, 38, yeah. Then the other side is 38. So then that's why it works. Yeah. Well, if it's above 90 and you're in this region, you can still draw a triangle for that region. So if it's like 110, cos will be negative. Yeah.
So negative cos 1 would be
Ooh. Now you're really doing deep thinking. So this is now year 11 stuff you're talking about. So cos of 120. So if you draw that. So cos of 120, you're right. So 120 is this way. Let's do it again. So 120 is somewhere over here. That means this is 60. So cos of, if that's 60 there, cos is the x length. Then you can also do this little bit here. That's 30 degrees there. So you can think of it as, if that's 30 there, that'll be the sine of 30 degrees, but you got to put a negative in front. Because you know this is negative on this side. Because sine of 30 gives you that length, but it's negative. So it'll be cos of 120 is equal to the negative of sine. Yeah.
Why is it cos?
Because it's equal to cos.
So you use the reference angle and then the reference angle to find. Yeah.
But this is a bit advanced. But if you can understand it, that's pretty good. That's like, I haven't taught you guys that. Yeah, that's a bit. Yes, that's another way of thinking about it. You can think of it as long as they add up to 90. Yeah. All right, team. Let's do an example together. Flip over the page. Let's flip over the page. So, at this level, all you need to be able to do... Thanks, team. All you need to be able to do is to read the graph and identify key features. So, amplitude and period is usually one of them. And the rest is knowing if one value is larger than the other. So, starting here, it says use the graph. They've given you a graph and they say find the value of cos of an angle and the angle's 200 degrees. Cos represents the x values. We've got a maximum of 1 and negative 1 because it always oscillates, right? So amplitude is 1. But now let's look at 200 degrees. 200 degrees is roughly, what, that's 90 to, that's what's 90 divided by 3? 30, yeah, that's right. So that means 210 is around here. So that's 210. So that means 200 degrees is roughly somewhere in between. So if we were to estimate, we can say it's probably, that's -1 at 180. So 200 degrees is roughly less than -1, maybe -0.9, maybe -0.8 or -0.85. That's an estimate because we can't tell unless the graph is drawn really clearly. And we can tell. So the value of cos of theta, where theta is 200 degrees, you can say approximately -0.9 or -0.8, somewhere there, because we're not 100% sure where the 200 degrees is, or -0.85 in between. Yeah. The two values of theta for which cos of theta equals 0.7. So what they're saying is what angle for this cos function to equal to 0.7. So if I'm looking at it, 0.7 is over here. There are only 2 points that I can see on the graph. This point right here and this point right here. That's when cos is 0.7. So the question is, what is theta? What's the angle for those 2 points? And again, you're estimating. So what's that? So 30 degrees back is 60. And that's 30. So it's in between 60 and 30. Yeah, maybe 50. Somewhere there. Possibly 50. Yeah, that's about right. 47, 50. Somewhere there. We're not 100% sure, but we know it's less than 60. Yeah? Because that's 30 and that's 60. So we're not really sure. It could be, if that's 60, that could be 50 there. We're not sure. It could be 45. Not 100% sure, but it's all about reading the graph. And your second point, this here is 300. This is 360. So again, it must be between 300 and 360. So it could be maybe
between 300 and 330.
345 again? 345 maybe?
Well, 345 would be above that last curve. It's 300.
Oh, sorry. This is 300. And that's 330. Whoops, my bad. So about 315. Roughly, yeah.
Violet, why do you make it so specific?
Sorry, I got the timeline wrong. It was 270, 300, and 330, so it must be between 300 and 330. So approximately 315. And this one was between 30 and 60, so maybe approximately 45 to 50, somewhere there. This one. So it said, when will cos equal to 0.7? There are 2 points on the graph where you have 0.7. So that means there are 2 angles that you can get that could get you 0.7. So far, so good. So that's the exercise for today. So reading amplitude, period, and then realizing cos is the x values and sine is the y values, and just relating to that. Yeah, approximately. Later on, you solve, but at the moment you're guessing.
Wait,
All right.
Is there a way to solve that?
Yeah. Cos inverse. You guys learnt cos inverse. So, in fact, if you solved for that before, you could have done cos inverse of 0.7, and they'll tell you exactly what the degrees would be. Yeah.
So if we can't use Desmos, can we just use that?
Yeah, you can. They are coordinates. Yeah.
Okay, that's way easier. Desmos is mean.
All right, last one. A and B, example 2. Use the graph of y equals sine of theta to state whether the following is true or false. Is sine of 30 greater than sine of 140? Let's find it. 140 is roughly here. So 140 is roughly there. Sine of 30 is over here. That's about 0.5. So false, I would say. Sine of 30 is roughly 0.5. And sine of 40 is possibly close to 0.7 or between 0.6 and 0.7. So false. B, sine 240 greater than sine of 290. 240. Yeah, so that's why it's false. Yeah. 240 and 290 could be somewhere here. All right. What's the answer for B? True or false?
True. Oh, false.
It is true. Because more negative, the more smaller it is. So sine of 240, obviously it's not as long, but it has to be then larger value. Because it's not as negative as 290. So sine of 240 is not as negative, hence why it is true. 290 is too negative.
Oh yeah.
Alright team, that's it for today's lesson. That's really just getting you to familiarize with sine and cosine graphs, amplitude and period. Next week we'll be doing sine rule and cosine rule the week after.